I'm Mackenzie.
And I'm Michael. So today we're talking about the limiting nutrient. So picture yourself in a horrible snowstorm. Like there's actually a snow day out here. But you're a pretty smart person, so you stocked up on some food from Nasty's. So you have some Cornell Smashes, 6 Cornell Smashes, 5 Bear Samplers, and 6 Frappuccinos. Now you don't know when the snowstorm will end. And it's Cornell, so you'll probably be stuck here forever anyways. So based on just the Cornell Smashes, it'll last you 3 days. For the Bear Samplers, it's 4 days. And for the Frappuccinos, it's 2. So which of these determines how long you can last? Now, obviously, it's a Frappuccino, because without coffee, no one will wake up, like ever. No, it's because you will run out of Frappuccinos first. And because you run out of it first, the Frappuccino would be your limiting nutrient. Now, just like us, other organisms may have their own Frappuccino, or nutrient that limits their growth. An organism may run out of phosphorus, nitrogen, or silicon first in their environment. Now, whichever nutrient will be used up first is their limiting nutrient. But unlike us college students, who can survive with just coffee, most organisms, they can't change which nutrients they need, and they rely on specific nutrients for survival. As a result, the limiting nutrient is the key resource that completely controls the growth and development of an organism.
Okay, so another module we used to learn about limiting nutrient was the Liebig's barrel, which shows that the shortest stave or section of the barrel is what controls the highest level which the water can rise to, otherwise it will spill out, which is analogous with the idea of an organism running out of the nutrient that it needs to grow. If you increase the length of the shortest stave, then another stave becomes the limiting nutrient, which also introduces the idea of secondary limiting nutrient, which we also learned in our favorite virtual lab, the Symbio lab, which we spent many hours of our lives on. And this taught us the concept of limiting nutrient by allowing us to manipulate the nutrient rates and showing the population sizes over a number of hours according to the nutrients which we made available to them. And it allowed us to play with death rate to create a more realistic environment and allowed us to look at the growth rate over multiple hours, as I said before, within just seconds. And it also introduced limiting nutrient by having us increase the amount of limiting nutrient and observing which nutrient then becomes the controlling factor of organisms' growth.
So a good way to connect our knowledge of the limiting nutrient is through global warming. So we did the Climate Change Summit when we presented in lecture, and that showed the consequences of pollution on the environment. And then in lab, we used algae to play with the effects of the limiting nutrient and to see how it impacted growth. So algae is good at absorbing temperature changes, and as climate change occurs, the Earth is warming up. In this case, algae is able to absorb this heat and slowly increase the temperature of the water it grows in and further climate change. And so in addition to that, algae also plays an important role in the carbon cycle, which is responsible for the accumulation of carbon over time. This indirectly leads to the intensification of the greenhouse gas effect and contributes to global warming. So when all the nutrients in an ecosystem are used up, including the limiting nutrient, the algae in that system dies, and a major source of oxygen production in that environment is lost. This causes an oxygen depletion, which can lead to the death of many fish in the water habitat and kind of mess up the food chain. If decreasing the amount of limiting nutrient available in a small-scale environment has such detrimental consequences, it is easy to imagine the large-scale repercussions of decreasing the limiting nutrient. On the other hand, increasing the amount of limiting nutrient available can have the opposite effect and increase the amount of oxygen emissions. So by looking at climate change and the limiting nutrients' role in global warming, we're able to increase our understanding of both concepts. Okay, so after learning the theory behind the limiting nutrient, we're able to design our own experiments based on what we learned in class. Using the tools we practiced with previously, we were able to measure cell density or optical density based on what we wanted to prove to test our hypothesis. So this was a great way to experiment with the different applications of the knowledge gained in this module. And overall, the limiting nutrient module exposed us to a few different concepts, including the limiting nutrient, secondary limiting nutrient, and its real-world applications. So now we just have 2 quick poll everywhere questions for you guys.
All right, so the question should be running. I'll go back to the slide.
So can you guys see the question all right? We're trying to find out the limiting nutrient.
Please raise your hand if you already answered the question.
That's most of them.
All right. Let's see those answers.
This is really good. 90% of the class is exceptional. The other 11%, let's just jump to the next question. Okay, so this is the most important question. If you don't get this right, you don't really understand the purpose of this class. So which one of these would you run out of first as a college student? Which one of these is your limiting nutrient? That is absolutely correct. It is the Frappuccino. Thank all of you for your wonderful attention.